Alright guys, today's goal, the learner will understand the fundamental theorem of algebra. The fundamental theorem of algebra. If f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. The key there is complex. Okay, because we've seen stuff before. If this is the graph, you see that, and it looks like it has no zeros, but it has complex zeros, imaginary zeros, okay? A corollary. If f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3 solutions, and so on and so on. What they're saying is if you get something like x minus 2 squared, that's x squared minus 4x plus 4. If you have that function, you would have x equals 2 twice. That's what they're talking about. So, how many zeros does the following function have? Well, what's the degree of it? It's 5, so it has 5 zeros. Number 2. Looks like 1, but the degree, so let's rewrite this so it's written correctly. What's the highest degree? 2, so it has 2 zeros. Okay? So what do we do with these zeros? Well, we find them. So, we learned how to do this. You could say plus or minus 9, plus or minus 3, plus or minus 1. Or we could check on our calculator, remember? So, let's check the calculator. X to the third plus 7x squared plus 15x plus 9, graph. Trace it. Well, -1 and -3 are 0, so use one of those. I'll use -1 since it's a smaller number. And remember, we do synthetic division. 1, 7, 15, 9. Bring down the 1, -1, 6, -6, 9, -9, 0. That's 1, not 11. So I'm left with x squared plus 6x plus 9 equals 0. Well, that's x plus 3 times x plus 3. Because we got to finish finding the zeros. So you get x plus 3 squared equals 0. Take the square root. So x equals -3. So you have x, all the zeros are -1 and -3, but -3 was twice. Okay? So go ahead and press pause and try the next one. So hopefully you did. So I see that -2 is one of the zeros. I have 1, -2, 0, because remember there's no x to the third. Remember that. You gotta have them all in there. Bring down the 1, -2, -4, 8, 8, -16, 8, -16, no, that would be -8, +16, 3, -6, 0. So now I have x to the fourth minus 4x to the third plus 8x squared minus 8x plus 3. Okay, well, I can't do grouping, so try to use the graph again. See, was there another 0? Yes, there was. It was at 1, so use 1. Bring it down. Let's see, negative 3. So 5. Negative 3. 0. So now I have x to the third minus 3x squared plus 5x minus 3. Okay, so we can't really factor that yet. So one of these has to be repeated twice. So let's check the 1 and see. So watch what we do here. Set it up again. So you say 1, negative 2, 3. See how we got 0? What that tells us is we have, so this tells us we have x plus 2. This tells us we have x minus 1. This tells us we have x minus 1 again. Now let's keep looking here. So what do we have left now? Now we have x squared minus 2x plus 3. So there's no way to factor this one. There's nothing that multiplies a positive 3 and adds a negative 2. So that's where you have to get these other two, they're imaginary, and you have to use the Pythagorean or quadratic formula. So I plug that in, I get 2 plus or minus 4 minus 12 square root of negative 8 over 2. But you have to ask, can you simplify this? Yep, that's going to be 2 plus or minus, the I comes out for the imaginary, plus I can change square root of 8 into square root of 4 and square root of 2, so it would be 2i square root of 2 divided by 2, which would be 1 plus or minus I times the square root of 2. So all of our zeros here, you have x equals negative 2, 1, 1, 1 plus or minus I times the square root of 2. Okay? Complex conjugates. If f is a polynomial function whose real coefficients are a plus bi, is an imaginary zero of f, then a minus bi is also there. So if I told you one of the zeros are, if I told you that something had a zero of negative 3i, also it has a zero of positive 3i. Or if I said it had a zero of negative 2, 5, 2 minus I, then it also has the 0, 2 plus I. Okay? So that's what that's saying. And same thing for irrational conjugate theorem. If I told you that it had a 0 of negative 2, 5, 1 plus the square root of 2, then it also has 1 minus the square root of 2. Okay? So let's take a look at how we use this. Write a polynomial function of the least degree that has rational coefficients and leading coefficient of 1 and the given zeros. Okay, so the given zeros, what that means here is x equaled negative 1, so I'm going to show an example. If we add it over, remember we got x plus 1 equals 0. So we have a factor of x plus 1. This would be x minus 2. This would be x plus 4. So I get x squared minus 2x plus x minus 2. I distribute it. Combine like terms. X squared minus x minus 2. Distribute. So you get, excuse me, x to the third plus 3x squared minus 6x minus 8. There's the polynomial function. So I look up here. What do we have to remember? Well, we have to remember 1 minus the square root of 5. Okay, so I know I have x minus 4, and then I have x minus 1 plus the square root of 5, x minus 1 minus the square root of 5. So I'm going to deal with the last two first and leave the x minus 4 there. So this one gets a little messy, but you have x squared. Oh, let me back up. Before I do that, let me distribute the negative for both. So it's x minus 1 minus the square root of 5, x minus 1 plus the square root of 5. Okay? Now we have to distribute. So I get x squared minus x plus x times the square root of 5 minus x plus 1 plus the square root of 5. I'm going to have to move this one over a little. Let's switch up to a different color. Plus the square root of 5, x times the square root of 5 minus the square root of 5 minus 5. Now I got to combine like terms. I still had x minus 4 there. So x squared is by itself. I see negative x, negative 2x, positive x times the square root of 5, positive x times the square root of 5. I feel like that should have went away though, so let me make sure. That's positive x times the square root of 5. That's negative x times that. So hold on a sec. This was a mistake. This should have been minus x times the square root of 5. So those cancel each other out. Then I have 1 minus the square root of 5 plus the square root of 5. So alright, I gotta back up here. This was too messy at the end. I gotta redo some of this here. Alright. So that's x squared minus x. plus x times the square root of 5 minus the x. That gives me minus x. That gives me plus 1. So this should say plus 1. And then minus the square root of 5. So this should be minus the square root of 5. And then I get minus the square root of 5x, which we already got rid of. And then plus the square root of 5 minus 5. So boom, 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 those are all gone. Now I gotta distribute this, so I get x to the third minus 2x squared minus 5x. That's why I said they get messy. That's why we gotta be careful. Minus 4x squared minus 8x plus 20. So final answer, x to the third minus 6x squared minus 13x plus 20. Okay? So those ones, they're not tougher. They're just, you got to make sure we're neat, and I was sloppy. Write a polynomial function of least degree. So same directions. But see, we got to add in 2 more. We got to add negative 2i. And we got to add 4 plus the square root of 6. I want to see you guys attempt to do that and bring that one in completed. I'm going to do the next one here. So we have 3 and 3 minus I, so we have to add 3 plus I. So I have x minus 3. Now I'm going to do this one, and then I have x minus 3 plus I, because these two switch. And then this would be x minus 3 minus I. If you're not sure about that, just know that happens, and I'll answer it tomorrow. Ask me, though. So now we got to distribute. Here comes more of the messy. So I get x squared minus 3x minus xi minus 3x plus 9 minus 3i plus xi minus 3i plus 1, because it'd be I squared, but I squared is negative 1. So I have all that. I still have the x minus 3, so combine like terms here. X squared minus 6x minus xi plus xi, gone. Minus 3i plus 3i, gone. 9 plus 1, 10. So x to the third minus 6x squared plus 10x. Oop, let me see, I'm getting sloppy again, and we saw what happened when we don't take time to write neatly. Minus 3x squared plus 18 x minus 30. Okay, so bring number 7 and complete it, guys. Combine like terms. Alright. Here's another problem I'm going to have you do. Approximate the real zeros for the following function. Use your calculator. Find all the real zeros using your calculator. Bring them in completed. See you guys later.